sends 1,800 bar of injection pressure to the fuel injector needles with piezo injectors, which distribute the power optimally in the combustion chamber. Due to the extremely quick reaction time in millisecond range, up to 5 separate injection processes can be achieved per cycle, which are also variable. In addition to the main injection processes, pre- and post-injection processes are also possible. Pre-injection moderates the acoustic hardness, the so-called rattling of the combustion process. Post-injection is specifically to raise the temperature of the exhaust gas and therefore for regeneration of the standard diesel particulate filter. These factors together allow exact, highly efficient combustion. The TDI turbochargers are part of a new generation. In the intake manifold of the engine, there are swirl flaps which are used to regulate the inflow of air in order to achieve optimal combustion. This use of technology allows high maximum torque of 5,400 RPM and clearly improves the thermodynamics in the combustion chambers. It allows the engine to run with a very high rate of back-fed and heavily cooled exhaust gas. The colder combustion with lower oxygen content massively lowers the output of nitrous
This section
oxide.
examines a basic carbureted system. A basic carburetor system consists of the fuel tank to store the fuel, fuel lines or pipes to carry fuel in the system, a pump to transfer fuel from the tank to the engine, a filter to clean the fuel, an air cleaner to supply clean air, a carburetor to atomize the fuel and provide the correct mixture of air and fuel, the engine intake manifold to deliver the air-fuel mixture to the engine.
Most diesel fuel injectors use the same basic design, made from heat-treated alloy steel. The actual shape will vary according to the application. The injector assembly has several main parts. The nozzle assembly is made up of a needle and body. A pressure spring and spindle hold the needle on the seat in the nozzle body. A nozzle holder, sometimes called the injector body, may allow for mounting the injector on the engine and some method of adjusting the spring force applied to the needle valve. A cover keeps out dirt and water. The injection pump delivers fuel to the injector. The fuel passes through a drilling in the nozzle body to a chamber above where the needle valve seats in the nozzle assembly. As fuel pressure in the injector gallery rises, it acts on the tapered shoulder of the needle valve, increasing the pressure until it overcomes the force from the spring and lifts the needle valve from its seat. The highly pressurized fuel enters the engine at a high velocity in an atomized spray. As soon as delivery from the pump stops, pressure under the needle tapered shoulder drops, and the spring force pushes the needle down on the seat, cutting off the fuel supply to the engine. Some of the fuel is allowed to leak between the nozzle needle and the body to cool and lubricate the injector. This fuel is collected by the leak-off line and returned to the fuel tank for later use. There are two main types of injector nozzle, hole and pintle. Hole-type nozzles are commonly used in direct injection engines. They can be single-hole or multi-hole, and they operate at very high pressures, up to 200 atmospheres. They give a hard spray which is necessary to penetrate the highly compressed air. The fuel has a high velocity and good atomization, which is desirable in open combustion chamber engines. In pintle-type nozzles, a pin, or pintle, protrudes through a spray hole. The shape of the pintle determines the shape of the spray and the atomization of the spray pattern. Pintle nozzles open at lower pressures than hole-type nozzles. They're used in indirect injection engines, where the fuel has a comparatively short distance to travel and the air is not as compressed as in the main chamber.